In this lecture, we're going to finish up the blue team trace phase and get ready to build another detection, which will kind of get us towards the wrap up of this solo purple teaming course. So we're going to go ahead and just jump right into a demo. Now, I've copied all of the chunks of base 64 into Cyberchef, and I've converted those to decimal, pasted all those decimal chunks into Cyberchef, and was able to decode the decimal. And now what I'm going to do is just save that output to a file, and I'm going to call this payload.exe. And we'll save that. And I need to keep it. And now we have payload.exe in downloads file. Now I'm going to just go grab the hash off that. So let's just open up PowerShell and CD into the downloads. Let's see if I can make this font a little bit bigger. Alright, so I'm in downloads. I'm going to get the file hash off that payload.exe file. And you can see here's the hash for that file. Now let's compare that to our service scan demo. So what I'll do is do get file hash on the binary that we created, which is in C:/users reverse engineer source repos service scan bin x64 debug service scan dot demo. It was called service scan demo, so I need to go back here. Demo service scan demo bin x64 debug service scan demo.exe. And notice that the file that we extracted from the PCAPs has the exact same hash. It means they're the same files. So we literally extracted the payload out of the PCAPs. And that's, like I said in the last lecture, those are skills you need as a defender, especially on the incident response side within the SOC and within the forensics and malware analysis teams also. So one thing you can do, you could do some other malware analysis on this if you would like. You could actually use CFF Explorer to open that file. So if you wanted to get more info about it. So let me go ahead and resize this again, try this again. Let's find the downloads folder. So I'm going to go to downloads and just drop payload in CFF Explorer, which will give you some information. So it's a portable 64 .NET assembly. Now once you see it's a .NET assembly, you can use a tool like DNS Spy to actually reverse engineer it and actually extract the .NET code. So that's one thing you do. You get the MD5 and the SHA-1 and the SHA-256, or the MD5 and SHA-1 hashes here. You can also see that with the static analysis, this will allow you to take a look at all the header information, the section headers, and so forth. So there's .text, .rc. Let's go ahead and open DNS Spy here, and we'll use DNS Spy to take a look at this. So we'll do File, Open, and we'll go to Downloads and go to our payload.exe. So now notice that it pulled that out for us here, Service Scan Demo. We can actually take a look at it. And here's the program. Here's all the code. So DNS spy, well, basically reverse engineer .NET assemblies for you. And you can see this is code is just exactly our code. Now, let me see if I can go to view, increase the font size. And so now you take a look at the code, you can see this is exact code that we wrote. So from a malware analysis perspective or a defender's perspective, if you're able to pull payloads out of your logs, like sometimes you'll catch them in the WMI logs and you'll be able to extract them out. Sometimes you'll catch them across the PCAPs and be able to extract them out. And when you can do that and then reassemble them as a binary, then you can do full malware analysis on those binaries. All right, so before you move on to the next lecture, go ahead, pull down the binary that you've put, hopefully have already put back together, and conduct any malware analysis that you would like to on it. Reverse engineer it, look at it in DNS Spy, grab the hashes, do some stack analysis on it. Just practice those skills and take notes and see if there's anything that you can determine. Now we wrote the binary so we know how it works, but there may be, it's good to practice the defensive side of reverse engineering, even tools that you write, and malware analysis of those same tools. So in the next lecture, we're going to move on to building a detection for the run MRU. We know those commands are stored in there, so we can check those registry modifications and see what the details of those registry modifications are to build a detection.